Hello and welcome. This is Peter, and the first thing I'd like to do is say thank you very much for listening. I really appreciate you, so thank you for listening to this audio. This audio is going to be about the history of SeETL a little bit, right? Now, why would I make an audio about the history of SeETL a little bit? Well, because SeETL is intended to be used by people like me. And people like me are long-term experienced data warehouse architects, right? Done lots of projects in lots of places using lots of data models. That's who's intended to use SeETL. Guys like you, if you're listening to this and you're a long-term experienced data warehouse architect, that's who should be listening to this, okay? If what you do is data stage programming, informatica programming, and you want to move up in the world, then listen to this as well, okay? So that's who SeETL was intended to be used by. SeETL was intended to be used by me on my projects to make my projects cheaper to deliver so that I could get paid a fair and reasonable amount for my time, and we could win projects over the usual suspects of Teradata, IBM, and Oracle, right? I mean, the people that I compete against are Teradata, IBM, and Oracle, and I've got to beat them some way. So the way that I figured out how to beat them is to have cheaper development, because I couldn't affect the price of the hardware, I couldn't affect the price of the databases or the front-end tools, but I could affect the price of the development cycle. And SeETL was intended to affect the price of the development cycle. Now, people like me, we like to hear the story about how something got invented and why it got invented, because if we hear the story of how something got invented and why it got invented, and we can kind of fit it into our own mindset, we go, oh yeah, that makes sense. And when it makes sense, our level of willingness to then use that product is higher, okay? So this audio is intended for data warehouse architects, very talented, knowledgeable people who are thinking about using SeETL, and they want to listen to me talk about it to figure out, does this make sense? Should I use this thing? Okay, does this make sense? Should I use this thing? And you should be a data warehouse architect, right? So how did this version of SeETL come into existence? Well, back in 2002, Ralph Kimball was writing for DBMS magazine, and he asked me if I had anything I'd want to write for the magazine and put in a guest article for him. And I did. I wrote this guest article, and it went over really well. And Ralph said, hey, that was fantastic. You get a lot of feedback, good positive feedback on your article. Is there anything else you want to talk about? And I was having this conversation over email with Ralph, and I was bitching up a storm about Informatica. I was implementing Informatica. I was implementing a Sybase IWS data model, and at a publisher, a newspaper in the US, and I was having a terrible time with Informatica, and we were actually having to change the data model in order to be able to load it with Informatica. And so Ralph and I were in this conversation about another article, and I was just bitching up a storm about ETL tools. And Ralph said, look, if you're so smart, why don't you write me an article about the features that the ETL tools should have in them, and we'll publish that, because that's a very popular topic. ETL is a popular topic. If someone like you says, well, here's the 10 features that ETL tools don't have that they should have, that's going to be a popular article. I went, oh, yeah, sure. Yeah, I'll write that. That's no problem, right? But the problem was, guys, I was working like 15, 16 hours a day. And I was on a timer. I had a limit because I was working in the US. And by now I'd been there for 6 months, and I had 3 more months of working there. And then I would have to leave, and I wouldn't be allowed back in, because I would have been there for 9 months as an Australian, and without a proper visa, they weren't going to let me back in. So I was on a timer, and we were working every hour the good Lord sent us, maybe a day off a fortnight, that sort of thing. So I didn't have time to write this article. And then when I got back, I went on a holiday, and I finally got back and I sat down and I wrote this article in about September 2002 after my long holiday. And I sent it to Ralph, and he said, "Oh, look, Pete, sorry, I've moved on from DBMS magazine. It's a great article, really like your ideas, but I've moved on, so I can't publish it." And I was like, "Oh, okay, well, that's fine. I did take 6 months to write it, so I can't really complain." And he said, "Look, these are great ideas. Why don't you? I understand what you're saying, that there should the ETL tool should have these features, but these are great ideas. Why don't you write an ETL tool yourself to put these ideas into practice?" And I said to him, we're having this backwards and forwards, and it's like, writing an ETL tool, that's a lot of work, and they're out there. If only those guys out there would use my ideas, then I wouldn't have to worry about this. And he's like, "Yeah, but if you write it yourself, you'll make some money out of it." And I'm like, "Yeah, I guess I could. But then I started thinking about it from a different angle. So I had this article I'd written for Ralph, and I was thinking about it from a different angle. And I was thinking, yeah, I could make some money out of if I wrote an ETL tool, I could make some money for it out of software. But realistically, a lot of people are going to buy an ETL tool from a one-person company. Is that really going to happen? And I was kind of a bit dubious about that. And I thought about it some more. And then I thought about it from the angle of, we pay a lot of money for ETL programmers on our projects, right? Like the ETL programmers, I was working for Sybase, and we were selling Informatica. And for our IWS implementation, I'm not kidding you, we had armies of Informatica programmers. I mean, we had lots of them. Because Informatica, back in those days, was about half the productivity profile of DataStage. So we're doing all these implementations all around the world. And, Sybase was an Informatica partner, so we were selling Informatica and being paid for it. Sybase was getting a commission from Informatica for selling Informatica. So we were selling IWS implementations like they were going out of fashion. But we just had armies of Informatica programmers. And the thought occurred to me, there must be a way to get rid of these Informatica programmers, because all we do, back in those days, what we were doing is we were doing the ETL mappings in the documentation in spreadsheets. We'd take this spreadsheet, sometimes even printing it, and we'd give the spreadsheet or the printed version of the spreadsheet to the Informatica programmer, right? And the Informatica programmer would take this spreadsheet and literally code into Informatica directly from the spreadsheet. So in Sybase, what I was doing is we're designing the data models, we're modifying the data models, customizing the data models for the particular client, and then we have to write down all the rules and everything else, and we're using Excel to document all that. And literally, we give either the printed version of the spreadsheet or the spreadsheet itself, one spreadsheet per mapping, or one workbook in a spreadsheet per mapping, and we literally give that to a programmer, and that programmer would sit down and code it, and then they give me the program back, and I'd have the documentation and the mapping in front of me in Informatica, and I'd read the documentation, I'd go through the mapping, and I'd be checking the programmer's work. This was really time-consuming stuff when you got a data warehouse with 100, 150 tables, 1,000 fields, 1,500 fields. That kind of size of warehouse is what we were implementing back in those days, and this was really time-consuming. So I was sitting there with this article I'd written for Ralph, and I'm thinking, damn, we just have so many Informatica programmers, and we spend so much time giving them this stuff, and they come back and going through that programming process. What if we didn't need any programmers? What if we had an ETL tool where we didn't actually have any ETL? We didn't have any separate place where these mappings were stored. So I started thinking about this, And I didn't even know if this is possible, right, at the time. So I started thinking about, what if we had a mappingless mapping tool? Now that sounds like a contradiction, right? And one of the things that I'd written down in my features was we should have a mappingless mapping tool. That is, the ETL tool should discover what it's supposed to do at runtime rather than having to be encoded at design time. What if we did that, right? And I was just sitting around the house because I'd had a long holiday. We had a ton of money in the bank, and I was just sitting around, didn't have a contract to go to, and we were planning to go back to Australia, so I was literally on time off, right? I'd been working, I worked absolutely flat out for the 9 months in the US, so we'd had a long holiday. This was my time off, and I had my feet up, and I was just thinking, right? This is late 2002. And so I said, mappingless and codeless, and so we don't have programmers. Let's see if we can do away with the ETL programming component. If we can get rid of the ETL programming component and move their work into my work, so I'm getting paid $150 an hour. Back then, I was paid $150 US an hour. So if I could take the program, all these programmers that we have, if we could take the programming work and move it into my area of work, one, that's good for me. And if what we need to be able to do is to take all this work away from the programmers and move it to my area, then we have to be able to cut the price in half over what we're paying. So we have to be far more productive than the programmers, 10 times. So the target I set was 10x, 10 times. I should be, if I do this work of the mappings, of the actual ETL, I should be 10 times more productive than the programmers, right? So we had a very well-defined process, writing these mapping spreadsheets, giving them to the programmer encoding them into Informatica, all very well defined, exactly, everyone knew exactly what they were doing. And then the question was, how do we automate the programmer's job? How do we do that? So the one more thing to explain before we get into it, and that is the number one problem. Oh my goodness. If I had much hair now, I would have pulled it out. The number one problem we used to have in data stage, and Informatica to an extent, but much more in data stage, is data type mismatches. That error message, there is a data type mismatch coming out of data stage, used to drive us crazy. Just varying lengths of characters and things like that, or integer to numeric conversions would give you all these data type mismatch messages. Now I was like, oh, I got to put this on here as well. It shouldn't generate something like a data type mismatch. If the data can be moved from one data type to another data type, it should be moved without a warning message at runtime, right? So the third feature I wrote down when I was just thinking about this article for Ralph was typeless. Okay? So the article that I wrote for Ralph had 3 big features along in like a list of 10 things it should do. But the 3 big features, number 1 was codeless. You should not have to write any code to build an ETL subsystem. No coding. No programmers, no coding. Save a lot of money, right? Codeless. Next thing was mappingless. All the ETL tools had these dictionaries which maintained all the mappings in them. So it should be mappingless. You shouldn't have to. The tool itself should not have to read a map of source to targets. There should be no map of source to targets at design time, right? The map for source to targets should be created at runtime. Okay? So codeless to get rid of the programmers, and mappingless to get rid of the the definitions of the mappings at design times, and typeless, so that we didn't have to worry about data, the type of the data being moved. As long as the tool could move it, it would move, and we should have a diagnostic program that we could run over this thing that would tell us if the data type could not be moved. And then if it told us that the data type could not be moved as a diagnostic, we could go fix it. But if the diagnostic program said, yeah, this mapping is okay, there's no data type mismatches, then the execution program should not give you any messages, and it should run. So when I said there's some extra programs, one of the extra programs is a diagnostic program to check for data type mismatches. So those were the three big things: typeless, codeless, and mappingless, so that we didn't have to convert the data types, we didn't have to write any mappings, we didn't have to write any code. That's where my thinking was in 2002. And I had that all written on paper. I said, well, this is interesting. Let's see if I can actually write this in C++. Because I'd never written C++, I'd written C. I was looking around at languages, and C as a language was going to be discontinued in its support for Microsoft in SQL Server 2005. SQL Server 2005 was not going to support the normal way of writing C. So C was going to be killed off for SQL Server, and Microsoft was saying you have to go to C++. So I thought, okay, well, I've got to write C++ and ODBC, so I've got to learn how to do that. And then once I do that, I've got to write a tool that is mappingless, codeless, and typeless, and see if I can do that. And so the very first program I had to write to figure out if this could be done at all was just a program to move data around between databases through a self-defining file. So I did that, and once I did that, I realized that yes, I did know how to write this ETL tool. Okay, I understood how to write the ETL tool. So the next step was following the standard advice that came with your university degree, which none of the ETL tool vendors have followed, is separate out your algorithms from your data structures, right? One of the professors I had, a guy called Jeffrey Dromey, actually wrote a book called Algorithms Plus Data Structures Equals Programs. And he emphasized way back in our university days that the access to the data and the algorithm should be separated. And this was taken as mantra in the 80s. I mean, the very first system I ever worked on at BHP had a thing called a data access module. Nobody was allowed, we were working with PL1 and IMS, nobody was allowed to access a database through their program. You had to use the database access modules to get to data. And the programs were purely algorithms. So you had to call a data access module, which would actually talk to the IMS database, and it would give you your data back in a way which was much easier to understand than an IMS database. And you would manipulate that data, and then you would give it back to the data access module to go and perform the updates. So even as when I started in 1982, the idea that the access to data and the algorithms were always separate, were always compartmentalized to make the algorithms easier to write, that was standard in 1982. Now, if you think about ETL tools, the data structures, the input and the output, every mapping in an ETL tool has a source and a target, right? The source and the target and the algorithm are embedded in the single mapping, meaning the source and the target and the algorithm, the data structures and the algorithm are collapsed into a single unit where when you maintain that single unit, you have to retest it because you may have damaged it, right? So all the ETL tools out there, all the ETL tools that have a GUI all follow the same pattern, where within the GUI that you're writing this piece of code in is stored the sources and the targets and the algorithm for manipulating them. The data structures and the algorithms are collapsed, meaning when you change the data structure or the algorithm, you must retest that. So this is how this came about. And I looked at that and went, well, that's not very smart. We have to separate out the data structures and the algorithms. So what we should do is write one program for each type of processing, and that should be the algorithm. And then the data structures, what it should do is it should go and open the source view and query the source view for the data structure, and open the target view and query the target view for the data structure, the fields and the data types. And then internally, it should write a map between that source and that target. And then the algorithm can apply itself to those sources and targets generated through that map. Meaning that each, let's say a type 1 dimension processing program, right? Type 1 dimensions are very simple, straightforward dimensions, and the processing for type 1 dimensions is very simple and straightforward. It's only about a 600-line C++ program, right? But it does all type 1 dimensions. What does it do? It opens up the source view, gets a list of columns and data types, opens up a target view, gets a list of columns and data types, creates a map between the two so that it knows which ones to move to based on column names, and then it just processes it. It reads a record in it, looks it up, and says, do I already have this record via this key? No? Okay, I do an insert. Do I have the record via a key? Yes? Okay, I do an update. It's a very straightforward program, but that program does all type 1 dimension table processing without any changes. All you need is a new input view and a new output view. So, great. That got rid of the programmer. Where was the mapping? The mapping was embedded in the column names of the source view and the target view. That's where the mapping was embedded. So I wrote all these programs, and there was one for each algorithm, basically. So you had a type 1 program, a type 2 dimension table processing program, a fact table processing program, and a fact association table processing program. 4 main programs, plus all the utilities and tools and other stuff that you'd like to have, right? And what that meant back then was all we have to do is from the mapping spreadsheet, we need to take the mapping spreadsheet as documentation. We give it to the DBA. The DBA creates views from the mapping spreadsheet, the source views over the staging area and the target views over the target area. And he maintains all those views according to the documentation. And then once the views are put over the source and over the target, it doesn't matter. It just runs. It just runs. And so by 2004, instead of having these armies of programmers for DataStage or Informatica, we had no DataStage Informatica programmers per se. We just had me, a DBA, and we build the ETL subsystem. And we go right through that process and testing everything and making sure everything worked and was fine, right? Now, I just have to add at this point, many of the customers we were selling to back then, the first places we did this was Saudi Telecom, and the second place we did this was Orange Telecom in Romania. So these are telephone companies, guys. These are not companies who are going to buy an ETL tool from some consultant living in Ireland, right? They're going to buy DataStage or Informatica. And in the case of Saudi Telecom and Orange Telecom Romania, they both bought DataStage because, in my opinion, and other people's opinion, DataStage was the better tool. So the Sybase reseller, although they were asked to sell Informatica, they sold DataStage because, in their opinion too, it was a better tool. So what we did, once we'd built the entire ETL subsystems in the development phase using SeETL, we invented a really cool way of migrating the SeETL, ETL across to DataStage, and then later Informatica as well, because it's trivial to do, right? So, although I say we didn't have any DataStage programmers, when we did the migration to DataStage, we did. Okay, so what we told the customer was, just because the customer's saying, tell us how many DataStage mappings you've done. What we would tell the customer is, oh, well, we have this way of doing things. We don't do the DataStage mappings until the end. Okay, and they're like, oh, okay, well, you guys are the experts. You're fine, right? And at the end, they got their DataStage ETL subsystem, right? But during the development process, we did all this development, all this work, all the mappings, all the testing, right up to systems testing. We did all that with SeETL. And because we did all that with SeETL, we were actually half the price that anybody else could do this stuff at. Because we didn't actually have a DataStage programmer. In both those cases, the DataStage programmers were actually the DBAs, the guys who were doing the database work. We just taught them a little bit about how to use DataStage, and they did the migrations for the SeETL, ETL across to DataStage, right? So that's how this all came about. Now, in 2004, when in Orange Romania, I was working with a Romanian company who was the Sybase reseller, and we got to the piece of the project which is convert all the mappings to views, right? So what we would do, what my job was, I'm designing the data model. I'm doing the data models customization, because IWS was a set of data models, and we would customize those data models. So my job was write this Excel spreadsheet, which was a mapping spreadsheet, as documentation, which included the instructions on how to change the data models, and I would give them to my DBA, right? And the DBA would change the data models in the Sybase Power Designer we were using. A great tool, Sybase Power Designer. So the DBA would change the models in the Sybase Power Designer. In that case, we were using Oracle, put them forward into Oracle. And he would do all this from the instructions in the mapping spreadsheet. Then once we had the target data model, we had the staging area, we had the target data model all done, and we had these, in this case, there was 4,000 fields, right? It was Oracle, the Orange Romania one was Oracle Applications, and it was Oracle Finance, and we were doing a financial data warehouse for Orange Telecom, and there was about 4,000 fields to be mapped, right? Which is a substantial data warehouse, guys. It's about 150 tables, about 4,000 fields, and it was all documented in this spreadsheet. And so then our trainee had got sold, and my DBA was going to have to do the cutting and pasting for the views, and my DBA was none too happy about that. His name was Adrian. So he said, why don't you save this spreadsheet as XML and then write some application to read the XML and generate these views. And if you do that, I'm not going to have to spend the next 4 weeks cutting and pasting and creating views, right? Like, his job would be to create, I think it was in the range of 150 mappings and 4,000 fields. I think it was in about that range. It's a long time ago. I could probably go look at the spreadsheet. But that was 2004, so it's 15 years ago. And that would take about 3 or 4 weeks of cutting and pasting. And young Adrian wasn't real keen on spending 3 or 4 weeks cutting and pasting and creating all these views. So I said to him, save this mapping spreadsheet, save this documentation as XML. I mean, I don't even know if you can do that. And he comes over to my laptop and goes File, Save As, and he says, see, there's this XML option. Sets it to XML, hits Save, saves the file. We go to the file and we open it up, and sure enough, here is XML saved by XL. I'm like, wow, I didn't even know that was possible. And it only came out in XL 2001, XL XP it came out in. So I'm like, hey, that's really cool. And Adrian points to the XML and says, you can easily write a VB program. VB's got XML processing in it. You can easily write a VB program to read this XML and generate the views. That's easy for you. And I'm like, yeah, it is. So this was like 6 o'clock on a Friday afternoon. This is like end of work. We're having we weren't having a beer. They were having a beer. I was just having a coffee or something. I couldn't drink back then. And so I went home, didn't get much sleep all weekend. By Monday morning, I actually had the first version of this Visual Basic application that would read, a test spreadsheet and generate the staging views and the target views. And I showed it to Adrian. He's like, yeah, see, told you that was easy. And so through the day, we worked on this VB application. And by the end of Monday, it actually worked. Like, by the end of the Monday, we actually had a prototype of this VB thing that would take the documentation spreadsheet, a sample thereof, and it had to be changed a little bit. There was extra things that needed to be put in there. Take the documentation thereof and generate the source to target mappings. He's like, see, now I don't have to spend 3 or 4 weeks doing this. I can do something a little bit more interesting. I'm like, yeah, okay, great. So literally by the Tuesday, we rejigged the documentation spreadsheet. We'd made all the changes we needed to make by the end of the Tuesday, I think it was. And we ran this thing through and we generated the source and target mappings. And by the Wednesday, we had it up and running. And I'm like, hey, that's really brilliant. We have no more cutting and pasting to create these views. We now have mappings. We still have mappings. They're in a spreadsheet, but the spreadsheet documentation has become source code and needs to be handled like source code. But we've just saved all this cutting and pasting work as well. That's all been removed from the project. So that's how the spreadsheet came to be. And then, of course, we're having a meeting at the end of the week, and Adrian was pointing out, now that you've got an XML reader, you've got a VB XML reader, anything that you want to manipulate, anything you want to store, you can just put it into a spreadsheet and store it and read it with its XML reader, and you can write to your target database. You can load like these control tables that we have. You can put them into workbooks and they can be loaded into the target database, and anything that ever comes up, you can just define another worksheet for it and send it into the database or generate from that worksheet. So this can become your development tool. And I'm like, that's a really good idea. That's a really good idea. And so it was. We started off, this is in 2004, we had the C++ engine at the back end for the runtime, and we started using Excel workbooks to record source code instead of documentation. And that's how it came about. Now, what did this mean for me, the data warehouse architect? What it meant for me, the data warehouse architect, is a whole lump of work that was previously sent to other guys that they got paid for fair and reasonable amount for their work. Their work came into my purview, and I would make more money on the project. Okay, I ate their lunch. I took their work, brought it into my purview, ate their lunch, and became responsible for the creation of the ETL subsystem, even the coding of it, except when we're going into production with Informatica or Data Stage. So I increased the amount of work for me on a project, increasing the amount of money I would be paid at a similar rate, and simultaneously decrease the cost of the project. Okay? And then when I was selling projects, I could go to a customer and I could say, we can do this project for you at this amount of money as a fixed price, and we know that we can do it. Now, carry this forward. You listening to this, you should be a data warehouse architect, right? You should be somebody who's a data warehouse architect or very experienced in ETL, wanting to move into that position. So think of it this way: when we have a very public example, being Carphone Warehouse. They've been a public reference for us since 2009. So we had Carphone Warehouse, the TalkTalk division. TalkTalk is in 2009, TalkTalk was a 4 million subscriber landline broadband company, making about £3 billion a year revenue. So quite a substantial company. And what they were doing was they were doing a billing systems migration project. So TalkTalk had come together as a series of acquisitions, and each acquisition had a different billing system, of course. And so they were doing a billing systems migration project to get all these billing systems from all these different telcos into their one billing system. And of course, all the data warehouses associated with all those old billing systems were going to die, and they needed a new data warehouse off the new billing system. So they went to that. This is TalkTalk. This is a £3 million, $4.5 million telephone company. They know who to go and talk to. So, they talk to the usual suspects, Teradata, IBM, and Oracle, and they ask for proposals. And they also talk to us, us meaning Sean Kelly and Associates, and I was working with Sean at the time. And they talked to us. So those were the four groups who got to actually put proposals on the table. IBM, Teradata, Oracle, and us. And I remember we were holding these meetings with them, and when we were finally going forward, we were holding these meetings with them, and they just said, "We flat out don't believe you." And I was sitting there with Sean in one of these meetings, and they're saying, "We flat out don't believe that you can do what you say you can do. We just flat out don't believe it." And Sean's like, "Okay." And I remember Greg sitting there shaking his head. He's like, you haven't seen the proposals from the other three, but the amount of money you are proposing for the services is less than half of the next best. And, we're talking, I'm not going to tell you who is the next best. We're talking Oracle, IBM, Teradata have put in their PS estimates. Your PS is less than half of the next cheapest PS quote. And these guys are good. These guys know what they're doing. These guys sell these deals all around the world every day. And we flat out don't believe that you can do this for less than half. We just don't believe it. And Sean, in his inimitable way, said, well, our proposal is capped fixed price. If we come in under our proposed amount, we will give you the money back. Okay, Greg? Literally, if we come in under our amount, we will give you the money back. If we go over the amount, we will eat it. And Greg's sitting there, he's like, that's kind of like the best deal I've had in a while. If you go faster, we don't believe you can do it this fast. If you go faster, you're going to eat the difference. You're going to give me my money back, and we can spend it somewhere else. And if you go over, you're going to eat it. That's a pretty good offer. And I remember Sean saying, we are so confident. He said, we are the best at this. And we are so confident that's the offer. And they took that away, and they're like, damn, that's... And Sean was the number one data warehousing guy in Europe. So TalkTalk was faced with the number one guy in Europe is telling you We are the best at this and we know how to do it. And so they eventually agreed for us to do the project on Netezza, because IBM's pushing their stuff, Teradata's obviously pushing their stuff, Oracle's pushing their stuff, and they had a Netezza box installed, and the question was for TalkTalk is, do we go away from Netezza and get something else, or do we do it with Netezza and Sean Kelly and Associates? So that was their big question. And eventually they chose us, and we went for it. Now, the guy who was voted for us, a guy called Brian Ganley, you can look him up on LinkedIn. Brian stood up at the Netezza 2009 user conference and said, and I quote, "The project with Sean Kelly and Associates had a productivity profile 5 times faster than our previous best efforts. And gentlemen, we're actually pretty good at this." And you could have heard a pin drop in the room, because this was one of the top BI people in the country working for Carphone. He was responsible for both Carphone Warehouse and TalkTalk Data Warehouses, because they were one company at the time. He stood up and said, he was very good, by the way. He stood up and said, "This is 5 times better, faster than our previous best efforts. And gentlemen, we're pretty good at this." And you just could have heard a pin drop. Now, when we did the project, Brian was he was the data business intelligence architect, Carphone Warehouse, TalkTalk, right? So he had a senior position in the company. At one of our early meetings, he comes along and says, "Okay, Pete, I want you to teach me how to use this SeETL thing." And I'm like, "You want to know how to use this? Really? I mean, in your position?" Guess it didn't make much sense, right? He had people to do this. He was very senior. He shouldn't be sitting down writing ETL. And he said, no, this is what you guys have talked about in the sales cycle. I want to be able to do it. I want to see it and do it and understand it. I went, okay, well, I'll train you, and you can write some mappings and knock yourself out. Okay. Hey, who am I to argue? And Brian and I became good pals. So he did this, and he's just like, this is unbelievable. And this was still the C++ engine. And as he started to understand what he was seeing and doing and using, he says to me one day, Pete, you've got everything in the mapping workbook. All your definitions are there, and you're doing the work inside your C++ engine. But you could push this into Netezza. Netezza is a fantastic box. It's really fast. You could push this processing into Netezza, and you wouldn't even need to have your C++ engine. You could generate SQL out of this spreadsheet and send it into the database, and it'll work. And I was like, oh, come on, Brian. I know you really like Netezza, and I hadn't been using Netezza yet. I'm just doing some small stuff on it and testing. So I hadn't used their production machine. We're just on a small development machine. And I said, I know you like it, and I know it's fast, but there's no way. I just can't see there's any way that an ETL subsystem can run inside a database. Just the workload is too much. So that's why we do it. Why we do it outside in C++ and data in memory and all this sort of stuff is the databases can't handle the workload. And he's like, yeah, but Pete, Netezza's different. Netezza's better. Netezza's faster. And he kept pushing Netezza. And I'm like, yeah, I know it's great, but I just can't see it. And so every day he'd come in and he'd tell me, you could generate SQL and you could put everything inside the database every day. And after about 3 or 4 weeks of this, we went to lunch on one Friday. And by then I was able to drink alcohol again. And so we had a beer at lunch. And I said to him, Brian, are you going to nag me until I do this? Are you just going to keep nagging me until I do this? And he smiled and said, of course. And I went, okay, look, this weekend I will test if SQL can work. What I'll do is I'll write the SQL that would be generated and I'll run it, but I guarantee you it won't work. Okay, it's just not going to work but I will write it, and I'll satisfy myself that it won't work, and I'll satisfy you that it won't work, right? And Brian says, yeah, sure, great. So this Saturday afternoon, I'm sitting there, because we had a lot of work to do. Remember, we were on capped fixed price, okay? Capped fixed price was our deal. And so anything I did that wasn't directly aimed at getting this work done, I was not getting paid for, right? If what I was doing was not directly aimed at getting this project done, I was not getting paid for that. We're on capped fixed price. So if I did anything outside of get this job done, that was my dime. So I was very focused on getting the job done. And there was a lot of work to do. So, it's not like we didn't have enough to do. We knew what we'd bitten off, and we were working hard to get it done. So anyhow, on the Saturday afternoon, I sit down and I say, okay, I'm going to write. We've got the standard tables, etc., etc. And we had 80 million CDRs for testing with. So I'm going to write a query to do the attribution process for these 80 million CDRs. And if memory serves me correctly, we had 22 keys on the CDR record. So we had to do 22 lookups to 22 dimension tables per record. And we had 80 million CDRs. And we were running this just on their small development server. And, I ran it once. It ran for like 4 hours and crashed. I'm like, yeah, this is what it's going to do, right? And I ran it again. It ran for like 3 hours and crashed. And, oh, yeah, that's what I would expect, right? And I'm feeling totally vindicated. But what I had trouble with cross joins. I was getting multiple rows. So it wasn't just producing 80 million rows as the output. It was producing a lot of rows as the output and crashing on disk, not enough disk, right? Because I only had enough disk. So it was literally a development machine. So we only really had enough disk to play with development style volumes. And this was generating 500 million or 1 billion rows and cross joins, and there was not that much disk. So that's why it was crashing. So the third time I ran it, and by now it's late because I started about midday. So we've had 4 hours. We had to write it. Took about an hour. Took about 4 hours to run. Changed it a little bit. 3 hours to run. So by now it was about 9 o'clock at night. And I'm running it again. And I'm thinking, well, this will be the last run. I'm going to go home, get my dinner after this. Because, I'm thinking it's going to be about 3 hours. It'll be nearly midnight. I'm going to go home, get my dinner, blah, blah, blah. I'm thinking that, right? And I'm just keeping an eye on the session and working on the work for the project. And the window comes back on my session. I'm like, and in 20 minutes, there's a window comes back. I'm like, I must have made a mistake in the changes that I made. So I go to the target table and I count the rows. And the number of rows is the 80 million. The number of rows is right. I'm like, that's interesting. And I go look at a few rows and the data's there. I'm like, that's interesting. And then I say, go look at the 22 keys and the keys are filled in. And I'm like, what? I'm thinking it's crashed. There's some reason it's crashed. So then I'm starting to do samples. I'm starting to do some queries and some joins to figure out, did the data go from the staging table into the target fact table properly? Because I'm thinking that there's been a failure. It hasn't worked, right? And it turns out it went in properly in 20 minutes. And I'm sitting there like, we just processed 80 million CDRs with 22 lookups from the staging area to the target in 20 minutes on the test machine, and they tell me that the production machine is about 5 times faster than the test machine? Are you kidding me? And I'm looking at this, and I don't even believe what I'm seeing, gentlemen. I don't even believe what I'm seeing. By now it's about 10 o'clock, and I'm thinking, I'm going to pay Brian back for all his nagging. I'm going to pay him back for all his nagging. And it's 10 o'clock on a Saturday night. So I call him, right? And everybody who works in customer-facing businesses like this, you don't call the data warehouse architect for a multi-billion-dollar company at 10 o'clock on a Saturday night, right? You know that's really very unusual and not normally done. And I call him because he's got my number in his phone, and he's like, Pete? I'm like, yeah? He's like, why are you calling me? And I said, well, you remember how you've been nagging me for the last 4 weeks? He goes, yes, I do remember that. I said, well, Brian, I've just been testing this, and I just did 80 million rows, just did the 80 million row test sample in 20 minutes. And I just thought you'd like to know you were right. I was wrong. You were right. And he just about died laughing. He's like, now he gets, why am I calling him at 10 o'clock he gets the joke, right? Why am I calling him at 10 o'clock on a Saturday night? Because he nagged me for the last 4 weeks. And he was right, and I was man enough to admit it, but I admitted it at 10 o'clock on a Saturday night. So he got the joke, right? He got the joke. He thought it was very funny. But then I sat down on the Sunday, and I wrote all the code necessary to generate all this SQL on Netezza. So by the Monday, when Brian came in, I said to him, I sat down with SeETL, and I put it in front of him, and I said, see this directory, which is empty? Okay, this little directory on my Windows PC. I said, see this directory, which is empty? He was like, yeah. Watch this. And I hit run on the Visual Basic program, and it took about 3-4 minutes. And then this directory just, boom, filled up with like 5,000 files. And Brian goes, yeah, okay, there's like 5,000 files there. So now let me open some of these up for you. And I opened them up, and inside what we had to do was do the SQL as multiple steps, and we put each step into a separate file. So a dimension processing program, for example, would take 3 steps. A type 1 dimension program would take 3 steps. I opened them up, and just something simple, and I said, here's step 1, here's step 2, here's step 3. SQL generated. All we have to do is, for the ETL subsystem, all we have to do is start at the top and throw these statements at the database. That's your ETL subsystem. And he's like, see, I told you this could be done. And he's like, what are the limitations? I'm like, well, the limitations are the SQL language implemented on Netezza. Anything that you can do on the Netezza machine, we can put into our generator. And that, gentlemen, is how we came to have the SQL generation version. Brian Ganley nagged me for a week. The Netezza machine was astonishingly fast, and what it produces, it just spits out the SQL that needs to be executed against the database as the SQL generation engine. So there's 2 engines. There's the older C++ engine, which on smaller accounts is perfectly okay. Just to give you an idea, gentlemen, the processing of 80 million CDRs on Informatica, taking them through Informatica, doing the lookups through Informatica, etc., that has a runtime of about 5 hours. At that time, it had a runtime of about 5 hours in production at TalkTalk. We were talking about being able to do exactly the same workload inside Netezza with no differences in 5 minutes. So 5 hours down to 5 minutes. Okay? That's the difference of not taking the database out of these database appliances, just processing it in there. Big 22 CPU Informatica machine. That's very nice. 5 hours to process 80 million CDRs. when that exact same workload was pushed into Netezza on their production machine, not this tiny little box we had for development, when they put it onto their production machine, that was 5 minutes in 2009. Okay? So that's what I wanted to say in this audio, gentlemen. This is how SeETL came about, right? It came about literally working on telephone company sized projects, trying to figure out, okay, well, we've got a standard way of implementing these data warehouses. Is there any better way? Is there any better way? And the better way turned out to be, instead of just using Excel as documentation and then cutting and pasting, copying, etc., the documentation across to an ETL tool, dispense with that altogether, make the Excel workbook the source code, and use it as source code and manage it as source code, and then read the Excel workbook with a generator that will take the data out of the Excel workbook, do with it whatever needs to be done, generate SQL, put stuff into databases, whatever needs to be done, and do away with the ETL programmers. That's how it works. Okay? And the person who is supposed to operate the Excel spreadsheet, the person who's supposed to put the instructions into the Excel spreadsheet for the generation of tables and indexes and mappings and all the rest of it, that person is a data warehouse architect, a very high paid, high IQ person. Okay? That should be you. If you're listening to this, the person who operates a spreadsheet is you. And you don't do this, well, writing ETL is beneath me. No. The person who operates the spreadsheet is the data warehouse architect. Okay? Now, in maintenance, you might get lesser skilled people to do the maintenance because everything is there and the maintenance is very easy. But in the design of what goes where from the staging area, what goes where into the target warehouse, that's a data warehouse architect's job. That's the guy who's designing the database is the same guy as the guy who designs the ETL. That's where you get your productivity benefit. And what it does is it moves the work from those other guys into the purview of the data warehouse architect. So guys like me, we have more work to do per project, and guys like the ETL programmers, they're out of luck. Okay? That's how that worked. Now with that, gentlemen, I'd like to say I hope you enjoyed this. I hope this was entertaining for you and that you thought it was okay. It's meant to be entertaining as well as educational. So I hope you enjoyed this little audio about where did SeETL come from, why was it invented, why was it a good idea, why has it been so productive. I hope you enjoyed that, and if you have any questions, obviously ask me. Obviously you have all the source code available to you. You have samples available to you. You're a data warehouse architect. You are more than intelligent enough to go and have a look at this and say, do I want to try this out with the thought of using it on my projects? Okay? Now with that, gentlemen, thank you very much for listening, and bye for now.